Okay. One, two, three. Okay, works. Okay, people are still coming in, so let's wait a little bit. Oh, wait a second. I think I have to disable. It will be a little bit yellower, whatever. So, I guess we can start. Hello, everyone. My name is Patryk, and today I will talk about 10 things that we have learned from running production infrastructure at Google over the last 20 years. Let me introduce myself. So I've been working in Google for 7 years as a site reliability engineer, in short SRE. I'm sure you've heard about name SRE. And today's talk will be about the experiences that we have learned, like we, the SRE at Google. So I will be sharing some of my experience as well as experience of my colleagues. So what is SRE exactly? Like, there are probably many definitions that you may have heard, like that SRE is like a philosophy or SRE is a job title. But let's take a look at what the inventor of SRE has to say about it. So that's Ben Traynor Sloss, who initiated SRE at Google. He was given a mission to design and run operations at Google in a way that a software engineer would. So so that's how SRE came to be. So instead of having separate developer teams and ops teams, Google aimed at having an ops team that wouldn't actually be ops team, but rather made of developers, so that they would approach production problems, like problems of maintaining production in a software engineering way. And I suppose SRE is about as old as DevOps, so most people can use these terms interchangeably. Well, there are slight differences there. Well, to me, it's mostly about the philosophy, how to run things, and a particular implementation of DevOps, but it also goes slightly beyond DevOps. And also in the name Site Reliability Engineering, you can see that there is a site in it. That's because Site Reliability Engineering was invented when Google was a site, right? There weren't that many products, like there was no Gmail, there weren't many other things there. So, well, you could say now that SRE is more like, at least on Google, it's like a Google Reliability Engineering. So that's how it's been initially. Google was just a single site, maybe with a few sub-sites. And now Google is made of many different sites, applications, both visible externally and those internal ones, and infrastructure. And SREs are involved in all these places. So SREs at Google work on products that are visible to customers. They work on infrastructure. However, they are not part of the developer teams. Instead of that, SREs are organized in a way that, well, there is a central SRE organization. So every SRE at Google belongs to that organization. And of course, they cooperate with developers very closely. However, they belong to other organizations. I'm talking about this because, well, this is actually important for SRE culture because, Google's a large company. It can afford hiring thousands of SREs, and in this way, the things that are organized, SREs can move from one area to another and spread the good SRE culture. And culture is the most important part of SRE. There is a saying. That culture eats strategy for breakfast. So no matter how much strategy you apply to whatever you do, maintaining production, developing codes, if you don't have a team that has a good culture of helping each other, of maintaining good practices, all this effort will be in vain. So yeah, today I'll be sharing with you 10 lessons that SRE has learned over the years at Google and how it shaped the culture of SRE. So the first lesson is that reliability cannot be taken for granted. So, when you have a production system that's running well, everything is fine, right? You don't have to care that much about reliability concerns. However, if that service stops being reliable, it's really expensive to bring it back to a good shape, right? So we argue here that there always has to be a voice of reliability. Whenever things are good or bad, somebody has to be there to care about all the risks that could make the system unreliable. So if there is no such voice, then you can only hope that the system will be reliable. But there is this famous SRE saying that hope is not a strategy. So yeah, that's not a good strategy if you don't care about reliability. So there is also this famous thing from the DevOps philosophy that you should shift left the planning for reliability. So the sooner you start thinking about reliability when developing your service, the better. So let's imagine that you develop a service that didn't have any reliability voice when it was designed, right? There wasn't anybody concerned about reliability when designing it. So this service is likely to be unreliable in the future, and it will be, well, it won't be impossible to make it reliable. It just will be very, very costly to make it reliable. So it's just a good investment to involve the people that care about reliability from the beginning. Right. So lesson number 2 is cattle versus pets. This also, well, the lesson is actually about uniformity and standardization. So this metaphor, cattle versus pets, is commonly used to describe 2 different ways how you can treat server machines. So you can have set of machines, and each machine is slightly different, each has its own name. They have different hardware configurations, they have different software running on it, or maybe similar, but there are some slight differences. And if you treat your machines this way, you have to remember about every single different thing. So you have to, it's like with taking care of animal pets, right? Each pet has its own name. You have to spend a lot of time caring about each one individually. However, if you approach server machines as similarly to cattle, you can think of machines as a herd of machines. So this way you can stop caring about every single machine. If you have a standard that each machine should follow, then yeah, it's just much easier to care about things at scale. Yeah. I guess this is most important at a large scale. So even if you don't have such concerns now, well, if your company is planning to grow in a year or 2 or 3, then this may be a concern. Of course, if you have your own server machines. But this can also be applied to services that you run. So even if you don't own your own machines, if you run things on some cloud, it's still important for different things that you're running, that you're developing, to be more or less uniform. So for example, you can apply this this approach to how you roll out new versions of software. If you have many different applications and each is rolled out to production in a different way, it has its own way of canarying the changes, then it's no good. So this is where SREs at Google come in. They one of their missions is to standardize the way software is managed. And yeah, so this is not only about making things more efficient from the cost perspective, it's also about reducing the cognitive load. And really, if you have too many different production machines or too many different pieces of software to run, it's just untenable to run this at a large scale. All right, so lesson number 3 is about blamelessness. So in a team that manages production, or in the developer team, well, anyone that's related to the software that's running on some servers, you should always assume that everyone is competent and well-intentioned, and also that everybody is behaving like rationally, and that their decisions are best to their current knowledge. Well, humans make errors, and humans can't make perfect decisions all the time, especially if their information is limited. So if there is an incident, if there is an outage, it's really unproductive to chase people that caused it, or maybe that communicated it. It's really unproductive. And even, well, if you have a person that caused an outage, how likely it is that the same kind of outage would happen again and again, but this time different people would cause it. So the problem is not with people, because people are just, people are unreliable. The problem is with the system that has been designed. So always think about how to improve the system that is causing these outages. And the processes may need fixing as well. So there's also a bit about psychological safety. So everybody must feel comfortable coming forward without fear of consequences. So imagine that you run a company in a way that introduces fear. So people are unlikely to report everything. They will fear that when they report something, that there will be consequences for them about this, whether they did it or whether they are just a messenger. So you should not shoot the messenger. You should actually encourage people to report as much as they know about things at production that may be important. So this way you can piece together more coherent image of what's going on in production right now, and better handle current incidents and better prepare for the future. There is also another risk that if people don't provide you all the information, they may be hiding some problems. So let's say they are hiding some small problems that, yeah, they are not important right now, but if there is a sufficient number of problems that are forgotten, swept away under the rug, they accumulate, and they can cause a mega outage. So you would really like to avoid having such a situation. Lesson number 4 is about measuring stuff. Measure what matters. So, well, I'm trying to convince you that you should measure things in production. It's more about having measurable goals. So let's say if you measure some numbers like the CPU or RAM usage on your server, that's great, but maybe it's not a goal, right? So if you are measuring numbers, maybe they will be useful someday, maybe not. It's really hard to say. On the other hand, you could have goals that are not measured, right? You can agree with your customer, with your clients, with a developer team that there are some goals to be met. But if you don't measure them, if you don't quantify them and measure them and store the historical data, it's really hard to do anything about this. So ideally, SREs and people alike should have measurable goals. It's also to avoid any kind of conflicts between SREs and developers, or SREs and product managers. It's the best way to avoid these communication conflicts. And when in doubt, always focus on the user, right? The mission of SREs is to provide reliability, but not at all costs. It's about like doing whatever is necessary to maximize the user's gain. It's just that. So in some areas, you have products that need to be stable, and you should do as little change as possible. And in other areas, like let's say users are using some new shiny app that needs versions every day or every week, then you should allow for more agility in this area. Another sub-lesson of this lesson is that anything you don't measure gets worse. So if there are any important things that you don't measure, it's always certain that they will get worse over time. It's just how the world works. Well, if it's otherwise, well, I'm happy for you, but it's just a stroke of luck. And another thing is to advise and not block people. So if you're too restrictive about these things, like if you require too much from your dev team, then they will find ways around these SLOs and the ways things are measured. So always listen to your developers. Maybe you could do this, implement this in an agile way, like step by step. First, maybe introduce some metrics, see if they work. Then maybe introduce some SLO on top of that, see if it works. If it doesn't work, you can always adjust this SLO or throw it into a bin and start with a new one, whatever works. So let's take a little break from these lessons and let's go back to one of the first slides to talk about ops. So SRE is not an ops team. As this founder of SRE said, SREs are supposed to design and run operations. So it's not 100% design and not 100% operations. It's a mix of both. But why should SREs do operations? Can't we have like SREs and an ops team so that SREs tell ops team what to do and ops team does this? Well, not really, at least not fully. So SREs are needed. SREs are needed in. SREs are needed in production. The SREs are needed in on-call. They have to take care of tickets, alerts, outages, because the best way to learn how a system works and how a system fails is watching its failure modes. Like nothing can replace hands-on experience. So on-call in SRE is not a purpose, it's a means to an end. So the idea is that SREs should spend significant time dealing with production issues, being on-call, so that they learn what's happening in production. Well, usually the problem is a different one, like people use SREs as ops teams, or try to convince them to be ops teams, but SREs are, I believe that people that are hired as SREs are good at pushing back on this kind of model, and they should push back, because that's against the idea of SRE. Okay, so failures are complex, easy to misinterpret, and easy to misinterpret from a distance, right? So if you have SREs that are working on broad areas, that are working on many different areas of your production system, they can learn things that otherwise would be impossible to notice. So for example, there could be some pattern of outages that is happening across products, across teams. And only if you have people that are focusing on different areas, then you can notice these patterns. Sometimes it takes even more work to notice these things. So for example, you can notice some patterns over large periods of time. And that's why it's important to register all the things that you know about the outages. It's important to keep track of each outage. Ideally, SREs should log whatever they discover during the outages in some, well, in a form of a document or in some database, so that after that people can take a look at the outages and find common patterns, and maybe this way you can shape the strategy of SRE in your company. And yeah, the last point in this lesson is that you need skin in the game to build up credibility. So again, this means that SREs should be working hands-on on outages, not only for the good of themselves, but also so that they are respected by the developers. Otherwise, how can developers trust SREs that they can handle production? Lesson number 6, no heroes. So it's not to say that SREs are not heroes of the production. It's the problem is with the acts of heroism themselves. So if we encourage people to be heroes, that creates bad incentives. So let's imagine that there is an SRE extinguishing small fires. But if we incentivize being heroes, then they can think, oh, well, I can just let this fire grow a little bit, and a little bit more, and a little bit more, and I will just extinguish this big fire, and I will be a hero of the company. So, well, this is bad because, first of all, this can lead to a burnout. Well, no pun intended, actually. And also, this production outage can overwhelm this SRE, and then the problem is big, right? On the other hand, well, maybe not on the other hand, but from a different perspective. I was talking here about an individual SRE, but this is also a problem for the teams. So let's imagine that an SRE team agreed to take care of some production system, but this production system is just very hard for the team to manage. Like, there are alerts firing all the time, the team gets pages over the weekend all the time, and in such situation, an SRE team should not be a hero. SRE team should push back to the developers and say, sorry, we have to go back to the whiteboard and discuss how we want to alert for the things, how reliable the system really can be, because this will not work in the long term. Okay, another point. The on-caller's job is to make sure that the problem is fixed, not that they fix the problem with their hands. So this includes like looping people in to investigation. This also means that the main problem can wait. That's maybe the current problem, like a fire to extinguish, can be extinguished now, and they can do the work to prevent another fire slightly later. Yeah, this goes along well with the principle that the on-caller is never alone. So whether that means that there are other teams of the SRE team, or maybe some other SRE team, like, you know, in Google we have plenty of SRE teams, so we frequently escalate to each other, and this is expected, right? I personally would definitely I prefer when people escalate to me with some things, even if I'm not on call, but then at least I have this safety that I can ask people around about things when I need help. Lesson number 7, automate yourself out of your current job. So this is here I'm arguing that you should always think about automating things, even if this seems to be not worthy, right? So, of course, don't send a human to do a robot's job, and there are numerous reasons why machines are better at many jobs, like, for example, adding entries to configuration files, or whatever that computer systems are better. So even if at current scale you have some manual tasks to do that could be automated, and you think, oh, this is fine, like I can handle like 2 tickets per day, I can just write a little bit of configuration here and there. But if your system is going to grow, you will need that automation eventually. So when are you going to do this? When you have lots of tickets, when you will have to deal with 100 tickets a day, or maybe now that you have 2 tickets a day. So of course there is always a trade-off between like spending time automating things and doing them by hand. It's just make sure that you take the growth aspect into account. Sometimes just impossible to do things by hand. So sometimes you'll just hit an obstacle that you cannot overcome, or maybe you can hire an army of people to deal with the problem, but maybe it's time to write automation. Also, it's not only about the time and money, it's also about consistency. So machines make less typos than humans. So sometimes it's really crucial to have precisely the right configuration. Otherwise, there will be some outage or your company will lose money. So another benefit of working on automation is that once you have automated the boring tasks, you can spend time working on something more exciting, like, I don't know, coding or looking at some other areas of production that you didn't have time to look at. So this is also an opportunity for SREs to change something in their jobs. Like if they're, for example, bored working on the same thing 2 years in a row, that's a perfect opportunity for them to take a look at something new and let the automation do the old thing. So that's an opportunity for SREs to change. And this is one of the few true things in production, that change is constant, I guess, in many aspects of life. And this affects many parts of production. And well, I was talking about the change in work, but also changes in production are something that we should talk about here. So change is the #1 reason for outages. So again, being a devil's advocate, you could say, okay, if this is true, then we should not do any changes at all. Just run the system, don't touch it. But then we would find ourselves without jobs, and also it wouldn't really work. The company would also go bankrupt or out of business, because like you need new features, right? That's a way to keep the customers using your products. Like you have to address customers' needs, you have to grow your company and so on. If you don't do that, the company will stagnate. One of the SRE's goal is to minimize unnecessary risk from changes. And you can look at different areas that introduce risk. And for example, you can focus on these areas that are like low-hanging fruit. So for example, you can uniformize the way you do version rollouts or binary rollouts in your different products, and this way reduce risk, right? Don't only test in production. Well, maybe even don't test in production. That goes without saying why. Use GitOps. Well, GitOps is just a word that's quite popular right now, but what I mean behind GitOps is that the code that runs on production, it should come, I mean, the binaries that run on production, or whatever, if you use interpreter, the code that runs on production, it should come from a specific repository. It should be versioned and code reviewed. What else? The binaries that you build, they should be built hermetically, and the build should be reproducible. So if you build the same binary, I don't know, 10 times in a row, it should always produce the same binary. And also, this is the same principle could be applied to production environment. So this should also be checked in and versioned. That's the ideal situation, because if there is an outage, you can always trace back. In most scenarios, it really helps to trace back to what version of code has caused this, and what version of configuration has caused this. And if you do so, as prescribed here, it will be much easier. Again, one of the things that people commonly talk is that you shouldn't deploy on Fridays. In some countries, Fridays are not Fridays, but Thursdays, for example. So if you're working with people from different countries, based in different countries, you should take this into account. And you shouldn't do too many production freezes. Like again, you could think that if changes in production are so scary, maybe we should do fewer of them, or maybe we should apply some tactical production freezes here and there. And it's great, like for example, during some holiday season periods, Black Friday, whatever, but this isn't really going to help in a long term. Like this should be applied really sparingly, because every time a production freeze ends, suddenly there is a lot of things introduced to production that change. And not only it's a lot of them, they can also interact with each other. And also this slows down velocity of the developers and makes the developers unhappy. Okay, lesson number 9 is that outages are inevitable. So it's impossible to avoid outages. Like they will happen from time to time, more or less frequently, but they will happen. So the goal is not to prevent the outages, but minimize the risk and minimize the damage. So when handling an outage, the best thing that you can do is to mitigate it first and ask questions later. Because when production is on fire, there isn't really that much time to fully investigate the issue, right? So make sure to extinguish all the fires and then investigate later. Beforehand, make sure that you will have such problems that can be extinguished easy, right? Be able to roll back your change quickly. This should be relatively easy done for stateless services, not so easy for stateful services, but well, they have to be taken care of differently. Use written communication for incident management. So this is something that I talked about earlier. That when investigating outages, ideally people who do that should write it down in some distributed document. Free form with some short entries with dates and times, so that people can later look at this and create a postmortem out of such a document. Or people can join such a debugging effort. They can look at the current state, what has been going on for the last couple of hours or couple of days, and help investigating it further. Also, organizational transparency helps a lot. So let's imagine a situation that we have several teams, and each team has a set of repositories, and they are siloed, they are isolated, they don't have access between different repositories. So this way, people from one team cannot access the repositories of another team, and it really hinders debugging. It's like if there is an outage that spans multiple teams, it really slows down debugging. Why? Because people should read code, not the documentation, like ideally like self-documenting code. So, and also, well, documentation can be mostly is out of date. So if there was a recent change, it may be undocumented. Maybe that change has caused the outage. And finally, you always need to have a backup. No haunted graveyards. So what that means? Haunted graveyard is a system that becomes so fragile and complex that no one dares to touch it. Raise your hand if you have no haunted graveyards in your system. Okay, everybody has some haunted graveyards in their production. Right, so how do we get there? Like, do people intentionally create haunted graveyards? Well, nobody does it, right? Somehow they create on their own. So systems start relatively simple. Maybe some of them start a little bit complex, but they become more and more complex over time. And it's not only that. Well, if you end up with a very complex system, it will be prone to breakage. Like every time you have a complex system and you change something in it or somewhere around the system, there is a high chance the system will break. Every time a system breaks and it's not fixed properly, it creates a so-called broken window. So if you accumulate enough broken windows, you may end up with a haunted graveyard, right? So there are some things that occasionally break in the systems and people say, okay, we know about this, it's well documented, we'll fix it later. But then that person changes company or team and forgets about it. New people come into the team, they see broken windows, they don't know what to do about them. They accept the seen state and do nothing about this. And that's the recipe for haunted graveyards. So yeah, the only way to prevent them is to care about the systems on a regular basis and also to, well, ideally design simple systems. It's much harder to design a simple system that does the job than a complex system, but it's really worth spending some time in the design phase, making sure you don't over-engineer your system, because it can really hurt production in the future. And of course, this again goes back to one of the principles that I mentioned in the beginning, that reliability cannot be taken for granted, that SREs should be involved, or similar people should be involved in the design phase so that systems are reliable from start. And reliable systems are usually simple systems. Right, and that would conclude 10 lessons. So let's see what we have learned, what are the common themes in these lessons. So relationships are important, right? Divided we fall, united we stand. So even though I told you that SRE is like a different organization at Google than the developer organizations, we still have this connection and feeling that we are in the same team. We are playing the same game here, right? We all care about production. And this is important to cultivate this culture of common responsibility of production. The best developers are these that care about production. Change, right? Change is inevitable, and well, it concerns what you're doing, and it concerns production. Like you can keep doing what you're doing forever. Eventually, you'll have to change what you're doing. So be open for whatever changes ahead. Otherwise, it will surprise you. Well, and if production doesn't improve over time, it may reach a tipping point after which it will become so unreliable that you'll have to just bulldoze the system and maybe build a new one. Engineering is important because no matter how hard you work, no matter how many principles you apply to your manual work, at a certain scale, it will stop scaling up, right? It will stop be sustainable. So you have to engineer automation to deal with the problems. And simplicity. Well, arguably in many production systems, boring is beautiful. Don't outsmart yourself because your future self is going to regret it. And that's all I have for today. Of course, I believe there is still for some questions, but thank you very much. And